Thank you indeed. It's funny, actually, I've been up here quite a few times before with the Coal Prep Society, but I've never actually given the presentation before, so this is a little bit new for me. So yeah, as I said, thank you very much, and we'll try and get through this. So tonight, I'd just like to talk, probably 15, 20 minutes, just on our online slurry particle density meters, the OSPDM, and really they are a bit of a new generation. We've been developing this equipment now for quite some time with CPT and earlier Tundra Clean Coal, and we've finally come to our, well, maybe not our final version, but certainly a version that's working very well and very reliably in the plant at Bloomfield. And even up front, I'd like to really thank Bloomfield Group for the work that they put into this and allowing us to test it on the site. Okay, so online slurry particle density meter, they sound quite a long name, but it certainly describes exactly what this thing is. It measures the average particle density in a slurry, and it does it online. Okay, but why did we bother to build such a device as the first thing? Right, as a process engineer, I wanted a way to control fines online in the plant. Okay, be it in a pilot plant, which would be very useful, and also just online in the plants and situation, also get incredibly useful. Dense medium circuits, not a problem. We can control them by varying the medium density up and down as we need to. In fact, we're probably controlling the total ash in that situation. But what about the fine circuits? Okay, that was the thing I was really searching for. Means of controlling the fine circuits, not just the total ash. Now, of course, ash is actually many of the things we're after, because that's our product quality. It becomes quite an interesting thing, the ash in there. But I thought, well, if ash is related to particle density, maybe the simplest, best and easiest way of going about controlling our fine circuits is to measure the particle density. I mean, we all know particle density, ash, quite well related. This comes straight from the ACPS monographs, okay? We can see particle relative density and ash, quite a good relationship, not a perfect relationship, and it's very important to remember that, okay? But nevertheless, a good relationship. So my thinking went, righto, I'll measure this relative density and I'll control ash. Of course, from other papers we've now presented, we actually found that that was actually a little bit wrong, because the relative density is a real term, ash is an artificial term, and it's the ash that actually gives you the errors. But that's probably another story. Righto, how are the fine circuits currently controlled? What do we do? I mean, right there, we've probably got an instrumentation, a piece of instrumentation that's controlling that flotation circuit. We do it by feel, by look, okay? By historical settings, we do have grab samples occasionally. We might get results back well after the whole situation has changed, the different feeders come in. There's been quite a lot of different control systems have been tried over the years for coal circuits. I'm not really going to go through them all now, but in reality, when we look at our plants right now, what we're using on our fine circuits right now in our plants, what do we have? We have the people having a look, and we have results often coming back at a delayed time. The only really online things that we have is we may use centrifuge torque in screen bowl centrifuges, thickness in a filter cake, that sort of thing. And that will give you information only about the product that you're producing, not on the tailings. Okay, so here I was, trying to measure just particle density. Very interesting. I'll mention this for a couple of reasons, because I contacted quite a lot of equipment suppliers and said, right, I want to measure particle density online. And quite a lot of them actually said that they could do that. The interesting thing is, though, they were making assumptions in that system. They might be measuring, slurry density, then assuming a solids concentration getting a particle density, or even vice versa. All of the available equipment made an assumption. And that, in coal preparation, was just not on, because all the streams within our plants, particularly now that we're measuring stuff with the OSPDM, we clearly see is very incredibly online. You can't make assumptions if you want accurate values. In fact, the simple Marcy scale that we're probably all familiar with, and the paddy had earlier that we had the digital ones. This is more the old style ones with a few more calculations in it. In fact, I'll go a bit of a closer up view here. That's the same thing, just the top right hand corner. With the old Marcy scales, you do have over the top here the pulp specific gravity, as they call it, which really is your slurry density. Okay? And really that's all a Marcy scale measures, is your slurry density. And say for dense medium circuits, circulating medium, that's fine. What they are also used for, and historically, is then relating that slurry density to solids concentration. Okay? And that's what you read off. And this is great, not that we use them a lot, but just to look at the relationship. If you have this pulp SG of 1.1, a particle density of 1.2, you'll have 55% solids by mass. The other end of the scale, these are just two different scales with different particle densities set in here. 1, 2, 1, 3, 1, 4, 1, 5, etc. Okay, this is the next scale, number 3, that comes up to 2.3. So if that's a clean coal, 55% solids at 1.1. If you have a very good reject, particle density of 2.3, you'll have only 16% solids. Okay? It shows you the interrelationship that you have between these factors. And if you measure just one factor, be it particle density, or say you measured solids concentration, and you assume a particle density, you'll be all over the shop. You'll have no idea what's going on in the process. That's the key. So, what we set out to do then was go, righto, we're going to measure each of those factors, the slurry density and the solids concentration. We're going to measure them individually. We're going to look at the accuracies that we need to measure that and determine the particle density. So our thinking was, that's it, we have the particle density, we can control the process. Now, slurry density. That turned out to be quite tricky. Again, don't forget, we've got to look at the accuracies we need for this device, which is quite tight, okay? Quite a lot of mathematics involved. Differential pressure was not accurate enough for what we wanted to do. Nucleonic, one we wanted to avoid. 2, again, not nearly accurate enough for what we needed here. We adapted equipment that's mainly used in the food industry and adapted it to work in the coal industry. All this stuff has been made to work and to last. As I said, this unit, in reality, has actually been going for more than 2 years now at Bloomfield without failure. But we found that the vibrating tube density monitors gave us very, very high accuracy. Certainly enough, particularly after we'd recalibrated and adapted them to the coal slurries. Solids concentration, that proved more problematic, and we always knew it would be. The slurry density, yeah, that we can handle very, very well. Ultrasonic units we tried, they really didn't, there's a whole stack of reasons they did not perform. We then went to microwave units, a couple of different types. And these were something that we really had to do a lot of work on. We found that the accuracy from them was not good enough for what we needed for our device. We pulled those devices apart. We found that whilst they may work very, very well on solutions, on slurries, it was a different matter. We've now found that we've pulled virtually everything out of those units, and we have completely re-engineered them. We may well work to building our own in the near longer term. We had to put in new software and even new hardware and actually measure other factors to get the accuracy there. Again, we're going for quite high accuracy within these units to give us the particle density accuracy. Now, all of this adds to the cost considerably. And those microwave units, once we've rebuilt them, are considerably more expensive than what you'll buy off the shelf. Now, I'll go back to it. So, our OSPDM, what is it? I've given you, well, it takes those things that we just looked at there and we monitor the average particle density. At Bloomfield, we've got it in the tailing stream, and the beauty of this thing is you can make any change you want to the flotation and you just see the response in the tailings particle density immediately. Okay? And of course that gives you an idea of how much coal is lost to tailings online. I will go back to a couple of other things about the OSPDM. But just before that, I would like to just go over a couple of things. Very interesting talking to a lot of people in the industry about density and different things and the understanding that people have. We pretty well all know what density is and specific gravity and relative density, but sometimes I find some people just get a little bit confused with other things. that particle density is referring to the density of the actual particles in a stream. If the whole thing, the whole particle, one big block, is, that's what you're getting the density of. Not the density of the liquid or the air or anything around it, it's the particle density. Slurry density, well, that is the density of slurry. That's what's measured by, probably quite inaccurately, as Paddy showed clearly earlier when he looked at the difference between his Marcy scale readings and your Weather readings. Huge, and that's another problem we find. But that's slurry density, it's the slurry mass over the slurry volume. Those two things are not the same, not by a long, long way, okay? And of course you've got solids concentration. Very, very important to remember with solids concentration for percent solids, two different things, by mass and by volume. They're not the same and should not be confused in any way. Okay, ash, and ash and particle density, again, it's another story. Don't confuse them. It's interesting. Particle density is a real term, ash is an artificial term. We've probably got to remember that about ash. The other thing is, as we've given before, of course, you can calculate mass yield from ash. Remember, that's always got errors from the ash test. Better way, probably, and the way we use a lot more now, is to calculate the mass yield from the particle density. Just do it directly. Don't bother with the ash test. So, I suppose this all comes back to our OSPDM, particle densities. Remember, coal's got a low particle density. Reject, it's got a high particle density. If you're measuring that online for the operators in a plant, if you're on the reject stream, you want that particle density high. Product stream, you want it low. It's real simple. It's interesting, when we actually had this on a plant in Queensland, we were trialling it. Back in those days, I was looking at relating particle density to ash, and actually the operators are going, why bother? It's easy, mate. Understand this. Tailings, high particle density, product low. Very simple. So we actually then just forgot about the ash correlation. Just work on particle density. So the OSPDM, what does it do? We measure solids concentration by volume, we measure slurry density, we then have to correct these densities for temperature, conductivity and some other factors that we now measure online. They improve the accuracy again, and we put that into our system. We patented to calculate the particle density. What sort of outputs do you get out of the machine? Okay, this is the Cytec from Bloomfield. Cytec trends, this is where normally we put the information up. Particle density, we'll see there in green, okay. Solids concentration by volume, solids concentration by mass, they're also very useful terms you can use in running the plant, and amazing how much they change. Of course, like any trend page, you'll overlay other information from the plant that will relate to it. Here they'll put the plant feed rate, screen bowl torque. We also put the conductivity. We need that for our measurements, but we also give that out from the machine, the Cytec, so that in itself is quite useful too. I'll come back to these things later. Obviously with such a device, the feed system is very important. We actually use a sampling spear to get the sample into our device. That spear's up there. We have a backflush system, we'll come through later. Interesting, we've done a lot of work on the position of that spear and that sort of thing. We actually found, we actually had 5 spears in, 6 I should say, at Bloomfield in this position. We found that there was very little difference with the one piping setup with the position of the spear, but of course there was a huge variation over time. That's the big thing. Taking a good sample, just the variation in time was far more than the variation in position. So if you were taking a sample to send to a lab, that's a very important thing. Because we're measuring it online, the variation with time is covered. Okay? From the feed system, which actually has got the top of it there of our deaeration tank, deaeration was also a major issue that we had to face with such a system. Any instrument that you have measuring slurry density, even conductivity, solids concentration, that sort of thing, any air in the stream will hammer it. We spent a lot of time getting that deaeration system just right. And of course with the slurry density measurement there, we could prove it was working very well quite simply by simply shutting the bottom valve and seeing if the slurry density went up over time. If air was escaping, and it never did, once we got the system right. Anyway, once we've got the feed, we then come down into the measuring tube system, where we have the slurry density measurement, mag flow, which we use for several things in the instrument, but mainly for triggering back flushing, making sure that the system's moving, our adapted microwave sol-con system, an interference valve, which we use to slow the velocity down through the system, but still maintain a big open diameter, which I'll talk about more in the future, and backflush valve. Very important for anything operating on the plant. We needed this to be operator free. It just had to run itself and look after itself for the guys to use it. Righto. So with the auto backflush system, and particularly the interference valve that we set up, we opened it up so that now we can take 20mm particles through the system. I mean, when the system first went in flotation, we worked on, maximum particle diameter of about 2mm should be coming through. We set it up with clearances to accommodate that, and then things aren't always that way. And that's what you get in most plants, and hey, you've really got to make the gear so that it will handle that. Otherwise it's blocking all the time, and the operators will just get the shits with the whole system, and they won't use it. So, with it, we've now made it that we can pass those particles 20mm through the system, and we've also actually put a second system in where we restrict anything over 10mm even getting there in the first place. So once it can get through, it's definitely going to pass. It doesn't block. Even if it does block, we have the automatic backflush systems, which take full pressure, clarified water back up the measuring tube itself and also the feed system. Equivalent to pulling everything apart, getting an operator up there, whacking the hose on and blasting it with full bore clarified water. Okay? And in the 18 months it's been running at Bluefield, it has never blocked. It has cleared itself, even after being shut down for periods. Oh, yeah, okay, nice. Nicholas, that's the upstream of water for the backflushing system. Did want to mention a little bit, and it goes a bit with Paddy's talk earlier about the calibration and sampling. With this unit and the calibration, because we're taking a side stream, as I said, we've done a lot of work to see that it is a good side stream. Okay, it is accurate. I'll just check my own time. So we got that, we think, quite well, but mind you, that changes situation to situation. We then sample the entire stream that flows through the unit for 15 resonance times. Right, the whole lot. No subdivision. What goes in for 15 resonance times we collect, and then that whole sample is analysed. Okay? We then compare that to the readings that come out of our system every second, and that's how we do the calibration. Well, that's the sample collection for the calibration. The next bit was the lab analysis. There is no Australian standards for slurry density or solids concentration, even though it's funny, we get a lot of those analyses every day, particularly the solids concentration, potentially a lot of errors in it. And the slurry density too, I should say. So we developed our own methods because we found that our equipment was more accurate than the lab tests. Okay? We've now swung that round the other way, taken a few things, sort of with the volumetric flasks, and actually taken that to a far higher standard, but again, we wanted extreme accuracy with these sort of tests. Every bit accuracy we have with the calibration gives us a higher accuracy in the output. So we developed a lot of new methods there. Acceptance trials. Bloomfield have now purchased this device and have it on their flotation tailings. We performed quite a lot of acceptance trials down there. And actually, these are the full 65 samples that were involved in that. No cherry picking here, this is the lot, everything that was taken from these tests. And it's interesting, when we did these tests, we deliberately, even though Bloomfield were happy for us to do it, we went, no, we want independent verification of this. Each set of 5 samples that were taken, and they were taken in over a short time period, we took samples 1 and 4 ourselves. We licensed another laboratory, Steel River Testing, Mick Campbell, and he went over our methods, agreed with them. He took samples 2 and 4, and on that we did our slurry densities, our solids concentrations and particle densities, and then sample number 3 was sent to a standard laboratory to do particle densities. Funny, we actually found the Australian standard particle density, or relative density, is not bad. It's pretty good. And We took control of our samples. Those other samples for the other laboratories were taken by Bloomfield staff. We didn't see them again, right? They did it just to make sure that we had true independent verification of everything we did. So that's the results. The system working very well. Here we did get a bit of a divergence, but we actually found that just at that point, maintenance, without telling us, or telling even the Bloomfield process staff, had changed the upstream system before our sample points and had changed the whole, essentially our calibration, our spear points, greatly reduced the height of the liquid within there. We found though, I did want to just put this in though, to get to show the true, everything about the equipment. Even though essentially it was now in a situation that had not been calibrated for and did not give perfect results, it certainly followed all the trends. When we went back and calibrated this afterwards, that divergence disappeared. Okay? Just quickly, just wanted to show a bit of the true power of this device. I mean, it's only on the tailing stream, but even that is very powerful. You can alter anything within the flotation system and see its effect upon the tailings immediately. No sampling, waiting for results. It's there straight away. You just here, for example, there's the particle density again, like we saw before, Solcon, by mass, by volume, screen bolt torque, which is still important. That's obviously a measure. How little bad it is another story of your product, and this particle density is a measure of your tailings. And plant feed rate, obviously, we want to do that. Look at how that's affecting it. This is pretty steady conditions. Increased collector, increased particle density. Right? Turn the collector off, your particle density starts to fall, and you see it immediately, as you'd expect. Back on, comes up, decreased frother, turn reagents off, particle density falls. I mean, they're things that you would expect. I suppose the real power of the unit comes in when it detects things that you don't expect. Like the other day, I believe it was very interesting. I was there, but Nicholas and Rod were. The plant, actually we haven't got this unfortunately, plant's going along, screen bolt torque sitting nice and level, but what happened was that the particle density went down in the tailings and the solids concentration came up. Okay, it's just indicating whatever the feed had changed. There was more coal in the feed, but probably all the collector was being used. There was coal then going out in tailings and it wasn't being measured. And if you just looked at screen bolt torque, you'd never see it. That's some of the power, some of the things you get from measuring the tails. Payback. Okay, we've thrown a hypothetical situation here. Oh, sorry. It's interesting. And it's not only Bloomfield we've tested this unit on, but this is where we have the long-term installation of it. Just going from 1.9 to 2.1 in the tailings by measuring it, which is 50 to 65. These are very achievable ASHOs. As I said, that's probably more the real number, but that's probably more relating to a number that people have in their minds and know historically. Okay? That can still create a lot of coal. These will be up on the web if you want to go through the numbers, okay, on the Coal Prep Society website. It's still only 6 days for the unit. We have also seen, both at Bloomfield and other places, what we call the near flotation failure. It's where something happens like a blockage in the collector dose rate. There's still some coming in, there's still frother going in. You're still producing froth off a flotation cell. Looks okay? Well, you could pick it up by looking at the filter and that sort of thing, but often it goes unnoticed for quite some time. Because you're looking at the particle density and you would pick that up immediately, hopefully you'll respond much quicker. In such a case, in this same plant, it's only an 18-hour payback, which could be made up of several units, okay? Several instances. It's not that long. So, as I said, the unit working well at Bloomfield, it has not needed an operator to look at it all in 18 months. Yes, we're there, but we have never cleared it. It clears itself, it runs. And once you've got that info, coming out particle density and solids concentration, what can you do with it? As an operator, as a process engineer, you can change things in the flotation. Change the collector, as I said, change the froth. Do what you want, change the froth depth, and you get the response immediately. What's actually happening? If the plant feed changes, you'll see it. It comes up. Yeah, and that's just on the tailings line. Obviously, process engineers will be doing pretty much the same thing, and they can also look to take that a bit of a step further, create set points for the operators and that sort of thing on flotation, which very hard to do. Of course, from management, we want to use, look at how much coal are you losing in the tailings. If it's on the tailing stream, of course, that's all about making money. That's particularly now. Of course, and we have put this on other streams. Right, they've said this, it's Bloomfield's on the flotation tailings, but there's absolutely no reason it can't go on the others. It takes 10mm particles through it, we'll pass them easily. We could potentially go larger, but 10's fine for the moment, I think, on all those systems. And of course, one of the big things we potentially see is spirals. That's where they go really well, okay? Getting an idea of it, product, reject, track that, and particularly the middlings, particularly places where you make a decision where you put the middlings, and how quickly you're getting information to be able to make that decision. The other big thing which we're looking to move with these is putting the OSPDMs around any process and the flow meter. Once you do that, you can then start to calculate your yields, have your qualities of product, have your coal losses in the tails. Okay? There's a lot you can do with that. You can get tonnage, you can get dollars. That starts to become quite a powerful system. I mean, this is the type of system also, has been tried in the past with other measurement devices. Those measurement devices didn't really survive for whatever reason, okay? This is one thing we've concentrated on getting the measurement device right. Now we can move on to tie this sort of thing together. Okay? So yes, this is not nucleonic. We make it locally from a lot of imported stuff, but nearly everything that we buy in, we rebuild to make it work in coal prep plants. That's what we really need to do. Now, our early stuff we could get it to work, we just had to get it very reliable, and that's what we've now achieved with what's happening at Bloomfield. Thank you very much for Bloomfield for putting one in.
Good job. That was very interesting. I think many of the, most of the plant managers know that we throw coal away in our tailings, in our fines reject streams, and this device seems has a lot of potential. And we talk about the management side of things, where management wants to know how much dollars they're throwing away, and then upper management wants to know how many pineapples to give because the plant managers are throwing all that coal away. It certainly sounds like a sound investment. So, so great work. A little bit concerned about the OSPDM.
It rolls off the tongue.
All right. Are there any questions for Noel?
Hey Noel, you said is it primarily used as an indication device there at Bloomfield, and have they tried using it to control any stream around flotation? Is there any scope there to actually use it for control?
Well,
yes, to all questions. The power of one people from Bloomfield, so we've been fiddling around with this thing for a number of years with Noel's group. It's a powerful tool if you can link it into your feed and your tails, and then you can get online your power and coal losses in it. We have tried it on a number of different streams. We've settled on the flotation tails for a number of reasons, because primarily you don't know how much you're losing in your flow tail systems there, so that's why we've settled on that system. If you put them anywhere you like, and yes, we have put that in other locations and trialled in other locations.
Yeah, sorry, my question actually was, what is it actually controlling, or is it more of an indication device?
It's an indication device, but you can set it up in your site tech, for instance. So if you notice an increase in your solids concentration in your tails coming through, and your particle density was starting to drop, you could then have it automated so you could increase your reagent additions. So is the question, have we linked it into process control systems in the plant? No, is the short answer to that. But can we? Yes, if you wanted to.
it's an instrument. It monitors things, right? How you then link it to your control systems, that's your, it's like measuring a pressure, measuring a density, but it measures particle density.
Any other questions?
No, the difference in density between something that's 9% ash and 10% ash is not very big.
No, that's
So
true.
What's the discrimination on a low
Okay,
ash?
that is a very good question. The interesting thing is, when you get to those levels, you have obviously you have a lot less mineral matter. We haven't yet truly determined how our accuracy will be on that stream, but from the work we've done, we found as you go to those the lower ash, lower mineral matter materials, actually the uncertainty in the device gets better. We can better discrepancy between them. So be interesting. I know what you're saying.
So you can probably tell, you've got a spiral, you're building on comfortably at 10, and
Yep.
then suddenly you go up to 20, you'll know you.
Oh, you pick that with a flash.
You pick and the shit's hit fan, but
Yeah. Okay, I agree, and we're yet to determine that. But again, as I said, it will actually get better as the ash gets lower. So yeah, we'll determine that one.
I guess the step changes will be very predictable.
Oh,
You'll pick them up very quickly.
yeah.
The gradual changes, is it it's capable of actually determining whether you've got a gradual increase
Oh, yeah.
in that?
Yeah, definitely. And that's what you see when you change a condition or the feed changes. Predicting the feed, actually, when it's running, you see a lot of very, very interesting things, and probably looking at variation in the feed that allegedly the mining department says it's not there.
All right. Any other questions?
Yep.
With haystack the way it is these days, I noticed in some of them slides you had mix-ups that didn't have safety clips in it.
Oh! Right. Well, we normally don't use mince-ups, actually. We prefer cam blocks.
It must have been on the other side of it.
It was around the other side. You didn't see it.
Any other questions? All right, hang on, one more, just in time.
What's an indication of how much it costs?
Oh, well, that's actually there in the slides.
Cost was there, 190.
Plus
Yeah.
one installation.
Yeah, it is. It's not cheap, but hey,
Sorry,
it's all right.
Is it, I didn't say that either, but, so, I'm with you, Paddy. The payback, obviously, if you can believe those numbers, and I haven't had a close look at them yet to believe them, but
Have a look.
it's certainly value for money. Absolutely, I think there's less pineapples coming if we get some of these instruments in.
Well, hope so. Yeah.
All right, good stuff. Any other questions? All right, let's thank Noel. Thank you very much.